Good day, everyone. So, today we shall be looking at another interesting topic that says mechanical energy transmission systems. In this topic, we shall be diving into the fundamental principles and applications of mechanical energy transmission, and our main focus will be on friction, belt drive, and chain drive. So, let's explore this together. All right, we're going to start with friction. The reason why we are looking at friction as the first thing is because we must transfer energy. Of course, there will be some opposing force that may not allow that energy to be transferred. So then, what is friction? How could friction be an obstruction to transmission of energy? We need to know what friction is then. Friction is a force that opposes motion or the tendency of motion between two surfaces in contact. So its own mission, the mission of friction, is to oppose motion or is to oppose the tendency of motion between two surfaces in contact. For example, look at this object and look at this young man trying to pull this object. The intention of the man is to pull this object forward and is applying a force called the pushing force, okay, or the pulling force, whatever case. But then, before this object can move, this man must be able to overcome an opposing force that is keeping it from moving, and that is called friction. Friction is always acting in opposite direction to motion. See the motion now in my right direction and friction in my left direction, meaning that it's trying to oppose. That's why we say it is an opposing force. So it's a force that opposes motion, as you could see here, or tend to oppose motion between two surfaces in contact. What are the surfaces now? The surfaces here are the ground surface and the object surface having contact with each other. Okay, so it is this friction that is preventing the motion between them. So what are the key characteristics of friction? Number one is to oppose motion. Number two, friction depends on the nature of the surface. Okay, imagine if this ground is a rough surface and this young man is trying to apply a force on this object. You will need to apply more force because the rough surface has higher friction. But if this surface is smooth, it will apply little force because the friction on the smooth surface is low. So friction depends on nature of the surface. That's the two characteristics of friction. Number one, it opposes motion. Number two, it depends on the nature of the surface that is acting on. Number three, friction is independent of relative speed. That is, friction does not really depend on the speed between the two surfaces in contact. Whether the speed between the surfaces is high or low does not change the nature of the friction. If the friction is high, it's high. If the friction is low, it's low. It's not affected by the speed at which the object is moving over the other object. And lastly, friction is proportional to normal reaction. What is normal reaction? Normal reaction is always a force that acts perpendicularly upward. Okay? It's a force that acts perpendicularly upward on an object. So, as normal reaction is increasing, the frictional force will also increase. So, these are the four characteristics of friction. Okay? When it is acting, when it's acting between two surfaces in contact against their motion. Right, so I will say this. What then are the types of friction we have? There are two major types of friction. We have the static friction. This type of friction occurs between two bodies that are not moving or that are at rest. When we say body at rest, that means they are not moving. So when two objects are not moving, the friction that is acting between them or between their surfaces is called the static friction. And the second type of friction is known as the dynamic friction. Dynamic friction occurs between bodies in relative motion. It's just like opposite the first one. The first one, it occurs between bodies that are not moving or that are at rest. But the dynamic one, according to the name dynamic, something that's moving, it occurs between surfaces that are actually moving, but friction is still occurring. It's just that during the movement, friction is being overcome. So these are the two major types of friction that we have. And then from the last characteristics of friction that we talk about here, that friction is proportional to normal reaction, it has generated this formula that is frictional force is equal to this symbol is called mu r, and it is tied to coefficient of friction. So this mu is called coefficient of friction. F, which is frictional force, equals mu times r. So this is a typical diagram that represents all these parameters. So the normal reaction that I mentioned earlier is a force that acts perpendicularly upward on any object. Then is the applied force. See this applied force as the man that is pulling the object. Then the frictional force acting against the applied force. And then of course, this down arrow represents the weight of the object. Weight always act downward. Okay? So we say that by formula, frictional force is usually the product of coefficient of friction, that is this mu, and the normal reaction. So in calculation, you might be asked to find frictional force and you'll be given coefficient of friction and normal reaction. Just multiply them. In the case where you have to find normal reaction and you are given frictional force and coefficient of friction, all you need to do is to divide frictional force by normal reaction, by coefficient of friction. And lastly, if you have to find coefficient of friction and you are given frictional force and normal reaction, all you need to do is to divide normal reaction, is to divide the frictional force by normal reaction. So any of them, okay, let's say a typical example now. A crate slide down an inclined plane with a frictional force of 40 Newton, that's our F, and a normal reaction of 50 Newton, that's our R. So the coefficient of dynamic friction is what? Is 0.8. That is, just divide divide 40. Okay, so divide 40 by 50. Okay, that's the frictional force. We divide frictional force, which is 40, by 50 with normal reaction, and that will give us 0.8 using this formula. Okay. So another example could be that you'll be given coefficient of friction, you'll be given frictional force, and you'll be asked to find the normal reaction. Still apply this formula using your mathematical arithmetic skills. All right. So what then are the advantages of friction? Does friction really have an advantage? C=opposite motion. Yes, friction has advantage. And one of the advantage is that it helps locomotion, it helps movement. Do you know that without friction, you won't be able to walk? It is because of the friction between the sole of your the feet and the ground, because there is friction between the two surfaces. That is why you could walk on the ground. If there is no friction, once you place your feet on the ground, you slip and fall off because there is no friction. So friction helps in locomotion, that is, help in movement and prevents slipping off. Number two, friction helps to secure nut, bolt, and nails. Imagine getting a hammer and a nail and hitting it on the wall. Do you know that that nail will not stay in the wall if there is no friction between the nail and the wall? It is because of the friction between them that allow nail to stay. The same thing applies to nut and bolt. Because the friction between the nut and bolt, that is why they could stay and hold whatever object they want to hold together. So friction really has an advantage. Another good thing about friction is that it helps in braking in vehicles. the brakes that we have in vehicles can be applied as a result of friction. That brake will be ineffective if there is no friction in the scene. So friction helps in stopping motion. That is, maybe if you have a sudden accident, run over by a pedestrian, with the help of friction, you'll be able to apply the brake. All right. Then blending too. Maybe you want to grind anything. Or our grinding machine also work with the principle of friction. If there is no friction, I tell you, the grinding machine will not be able to blend either your tomato or your pepper or your crayfish, whatever you want to blend. The grinding machine will not be able to blend because it will be too smooth. So instead of blending, it will just be slipping around the tomatoes. So with the principle of friction, you are able to blend. And also using stone. In the past, we use stone in blending. It is because of friction between the stones. That is why you could blend with the stone. And today we also use ladder in climbing. If there is no friction between the ground where the ladder is placed and the wall, I tell you, the ladder will not stay and the climber will likely fall down. So it's because friction exists. That is why the ladder can stay on the ground and the other hand can stay on the wall without slipping off. And lastly, we use friction in generating static electricity. As we see here, this example of static electricity. This is a generator called Van de Graaff generator, named after the inventor Paul Van de Graaff. How does the generator work? In this case, an electric motor is connected to a belt. You could see this electric motor here is two turning. Now this is the belt. The line around it is the belt. So once the motor starts moving, it turns the belt round and the belt generates this static charge which goes onto the bulb, and as it goes onto the bulb, anyone that touches the bulb, okay, will receive the charge. And look at this lady now. Once she touches this bulb now, they'll have been charged. Look at her hair will be what? Will be charged because of the accumulation of charge at the bulb. So how does friction apply here? Friction apply here because as the motor moves, there is friction between the motor and the belt, and as a result of that, electrostatic charge is generated, which is being carried by the belt and goes into the bulb, and at the point it will accumulate on the bulb and start discharging. Anyone that touches it, get his hair, okay, charged, and you could see the lady's hair, standing as a result of her touch, as a result of her touching the bulb of the Van de Graaff generator. So these are few out of many applications or advantages rather of friction. Of course, whatsoever had advantage must surely have disadvantage. So then we are going to look at disadvantages of friction. Number one, friction unfortunately can cause wearing and tearing on footwears. Today now we have reason to change our footwear because of wearing and tearing. And this wearing and tearing are caused by friction. By the time you keep wearing your footwear, the surface of your foot and the surface of the foot begin to what? Begin to move, and as a result of friction, begin to tear off. Okay? When the surface of your foot have contact with your footwear, there will be friction and gradually it gets it torn. Even tires too. Look at this tire now, is weighed up because as a result of the contact of the tire with the road, constant contact with the tire with the road, moving and touching the road wears off this tire, and this because of friction. If the road were to be smooth, definitely that will not be wearing off. So even some machine parts too get weared off because of friction. All right. So that's one disadvantage of friction. It causes wearing off. It causes tearing and cutting. As a result of friction, materials can get caught, material can get torn because of repeated what rubbing of the material together. Friction also reduces efficiency. Friction reduces efficiency when you are using a machine for a long time and it keep rubbing, the part of the machine keep rubbing each other. With time the machine will be wearing off, and instead of the machine to be more efficient, the efficiency will be what reduced, because as it wears off it can no longer perform the usual work it performs. And lastly, friction generates heat. When there is too much rubbing of parts, too much rubbing of part surfaces, it gradually leads to generation of heat, okay, especially in machine part. And this heat also can cause, can cause discomfort in the company or industry. So it can even destroy the machine with time. So these are the some of the disadvantages that friction has. All right. Now, how do we reduce friction in the case where it can cause disadvantage? In the case where in the case where friction can cause disadvantage, we apply lubricant. Lubrication. Lubricant are just oil or grease that you apply around the two surfaces. When you apply oil around the two surfaces, the friction will reduce. Another way of reducing friction is by using what we call the rollers. Sometimes these rollers also help in reducing friction. Okay, so it will replace that friction with that sliding friction. It will replace it with what rolling friction, because when something is rolling, it tends to reduce its friction than when it is sliding. So using rollers also reduces friction. Then ball bearings too help in reducing friction. When you apply little ball between the two surfaces, it helps in what? In reducing friction. And lastly, the use of belt or chain drive. Employing belt or chain drive in transmitting power sometimes reduces direct friction too. And then this will lead us to the next topic called the drive. Let us now explore in details what belt drive is. What are belt drives? You can see them here. These are the major two types. Generally, drives are devices that transmit rotary motion from one shaft to another. So if you want to transmit motion from one point to another, you make use of drive. Okay? And the one we are looking at right now is called the belt drive. It's called belt drive because it makes use of the shaft and the belt to move. As you can see here now, this black object is the belt. It's being tied around the shaft. The shaft is the move is the movement is the object moving. Okay, there are two. This one, this first one, this another one. Now the belt is pulled around the two shafts and it helps in transferring motion from the bigger shaft to the smaller shaft. So this helps in reducing friction instead of direct contact between the two shafts. The belt presence help in reducing friction. So this type of belt drive is called the straight belt lap. Okay, in this case, with these shafts are known as pulley. The two pulleys are moving in the same direction. You can see in a anti-clockwise direction. Both the first one and the second one, they are moving in the same direction. So that's what we call the straight belt lap. It's a type of belt drive whose two pulleys rotate in the same direction as they transfer their motion from one to the other. The second type of belt drive is called the cross belt lap. In this case, we also have two pulleys, okay, or two shafts, but they move in opposite direction. You can see one is moving in clockwise direction and the other one is moving in the anti-clockwise direction. And you can see that the belt actually cross. They perform the same purpose to transfer motion from one point to the other, or transfer energy from one end to the other in order to reduce friction. But then, belt drive cannot provide a positive drive. Why? Because the belt can easily slip off the shaft. And that is where the chain drive comes in to solve the problem of slipping off. So we do not regard belt drive as a positive drive. Rather, we see it as a negative drive because of the tendency of slipping of belt from the shaft or the pulley. So then the chain drive, does better. So let us explore the chain drive. Before the chain drive, let's look at how to also reduce this slipping a little. And that process is called the belt tensioning. The belt tensioning is just the application of extra pulleys that you can see here. The pulleys there are there to tension the belt so that it does not slip off the shaft. All right? And then we use belt drive in power generation. We use it in making, we can also find belt drive in grinding machine. We can find belt drive in automotive. We can find belt drive in electronics. In the past, before the invention of computer system, the invention of flash, okay, we use tape recorder in recording information. And this makes use of drive too. But today, it's now obsolete. So in the past, we make use of belt drive in tape recorder and also video cassette players. But it's not obsolete. But then we still apply them in automotive grinding machines and power generation. Since we could see the defect of the belt drive that can slip off, then there is need for us to explore the chain drive. Okay, this is a typical diagram of a chain drive. So the chain drive also transmits power, just like the belt drive, between shaft. But this time around, it makes use of chain and the sprockets. Okay, this is sprocket here that we refer to as the shaft in the belt drive. So the advantage of this over belt drive is that it does not slip off the sprocket, and it grip firmer. It grips better than that of belt drive. And in this case, the chain move in the same direction, just like we mentioned for that of straight lap. Okay. Now, where do we apply chain drive? We find chain drive in motorcycle. We could find it in bicycles, and we could also find it in mechanical saws. Right? Now, let us look at the comparison between chain drive and gear drive. So this is gear drive here, this is chain drive. What are the comparison between the all differences? So for chain drive, you could see that power is being transmitted between the shaft at some distance. So you could see that the distance between the two shafts, okay, using the chain. Unlike the gear drive, where power is being transmitted very closely with the two shafts touching each other. You see, there is no any belt here, neither is there any chain for gear drive. But for chain drive, we could see chain, like the distance between the two shafts. Number two, we have positive power transmission, that is no friction for this, for chain drive. However, for gear drive, obviously you could see that there is friction between the teeth of the gears. There is friction between them, they are clocking on each other. Thirdly, for chain drive, motion only between parallel shafts, okay, you see. But for gear drive, we have motion between parallel and inclined shafts, okay. So you could see that there is motion between the parallel shaft, this and this, and the one that are inclining themselves. And lastly, the driver and the driven sprocket rotate in the same direction. For chain, you can see the two of them are in the same direction. Meanwhile, for gear, the driver and the driven wheels are moving in opposite direction. This yellow one is moving in clockwise direction, while the other one is moving in anti-clockwise direction. All right, so we shall be doing the cutting here today on mechanical transmission of energy. I hope you have learned something in this lesson. Thank you for watching and have a wonderful day. Bye for now.